We're live. Cool. Are we live? We're live. Cool. Hello. Thank you for joining me on this. Well, it's kind of beautiful here. It's a little cloudy, but the sun's shining through. Just it's a pretty nice afternoon here in Victoria, and I hope it is wherever you are. Um, Today is day whatever of my series of live streams where I'm trying to make a version of Breakout for the Game Boy. Breakout being the classic ball and paddle game where you're breaking the bricks in an area. Um, and let me just boot up what we've got so far. So we got a ball, we got a paddle, you can press a button and the ball bounces around. Right now the ball, oh, and actually, yeah, we got that. And when the ball hits the bottom of the screen, it's a little too early. Maybe another tweak you should do. But when the ball hits the bottom of the screen, it bounces, or I mean, you die, and the ball restarts on your paddle. So today, instead of sort of taking the obvious next step and adding the bricks to the arena and turning this into an actual game, I actually wanted to take a little bit of time to just sort of do some cleanups and refactors of the code and maybe tweak some things. Like, for example, right now I just noticed when the ball hits the bottom of the screen, it's the bottom of the ball that hits the bottom of the screen, and it just looks like you're dying a little bit too quickly, and it would be nicer if the ball could just completely disappear off the screen. So some tweaks like that. So this is not going to be like a super challenging day, which is kind of the idea. My videos over the past couple of days have been kind of like sort of experimental, sort of like rambly as I try to figure out exactly how to solve any given problem. I'm hoping this will be a little more straightforward, the work that I do today, so I'll be able to explain things a little bit better, hopefully, while I do it, because I'm not, I'm using some amount of my brain on solving these problems that takes away from my ability to explain while I'm doing it. Also, at the end of it, I'm sort of hoping that this is going to be somehow educational, and I'd like to be imparting good practices, so good, clean code that is easy to understand and learn from is an ideal goal. So I want to work towards that. This will just be, it'll be fun, it'll be nice, and it'll help going forward. If the code is a little bit cleaner and a little bit easier to understand, it'll be easier to make changes in the future, hopefully, because, the problem with programming on the Game Boy is like, you have to tell the CPU every little thing that it has to do. There's not really a whole lot of abstraction or expressiveness in the assembly language. And just like keeping track of everything that's going on, it can be super hard to do in these long procedures. So breaking things up a little bit, maybe adding some macros. It's just gonna make my work in the future a little bit easier. So let's get to it, I guess. I'm gonna open up my bash as well, so I can save these changes piecemeal. So just like looking from the top, like in general, I like to like just go through things and be like, does that belong here? Can I move this somewhere else? So this module, this file is already like nearly 400 lines of code, and that's like, in my opinion, too large. I feel like, sometimes it's inevitable for your files to get a little bit large, but ideally, nothing more than like 100 lines of code. Like, any given procedure should fit on one screen. Your whole module should be less than 100 lines of code. That is my gold standard for readability. So for example, all this paddle stuff, why don't we make a dedicated module for the paddles, or for the paddle? So I'm going to just do that right now. I'm going to call this paddle.asm. And actually, these will probably go into an include file rather than into the paddle file, but eventually, maybe. But let's do this for now. And we'll get the paddle variables in here. And init paddle can go in here. I have to add a section for it. And all this update paddle stuff as well. Can go in here. Not super clear whether put ball into paddle or update ball and paddle, or put ball into paddle. That is a ball thing, but it's also kind of about the relationship between the ball and the paddle. So in a case like that, you kind of need to use taste and judgment as to exactly where that'll go. But for me, I think that's pretty clearly a ball thing rather than a paddle thing. And then let's get set up paddle OEM. Okay, there we go. So this is not gonna work, but well, let me add it to the make file as well. It's obviously not gonna work yet because I haven't exported anything from the paddle file. But the errors I get will tell me what I need to export. So let's hit build. Okay, so one thing we need is input left and input right. So we actually need to add that to paddle.asm. We need to include the input constants. Nice. And then, yeah, so we're going to need to actually split out the constants because they're used in breakout.asm. So we're going to split those out into another file. This is going to be paddle.asm. Because I assume they're using here too, right? Yeah, there's paddle width, paddle y, so cool. So next, what breaks now? So it looks like in the main file, we use these variables, paddle x, set up paddle OAM. It's unfortunate. I don't use VS Code normally. I probably should because it's kind of becoming an industry standard. Is there any... Like, it would be just really nice if I could press tab once and have it, you know. Oh, yeah, I can do that. Nice. So if I go to column selection mode and I just drag down along the column, that'll let me insert a tab everywhere. That'll be a lot more effective for keeping things lined up. Let's turn column selection mode off now. So now we also need update paddle and init paddle to be exported. These look like they're tabbed in too far. There we go, that's better. So now the only other thing, we do use paddle X globally. So I'll export that as well. And now we build, and let's pop open the debugger and see, reload the ROM and see if we broke anything. And we didn't. So like, look at that. Now breakout, this was like nearly 400 lines of code before, and now it's only 266 lines of code. And of course, the other really nice thing is that all of these things that we didn't export, we no longer sort of need to worry about them, like naming wise or anything like that. Like yesterday, when I added some input for the ball, I had to rename this to handle paddle input from, it was handle input before. But then I had like handle ball input. And so I needed a way to disambiguate them. And so it ends up being like this super, super long name. Well, now this isn't used outside of paddle.asm. So just by virtue of being private to the paddle.asm module, not exported anywhere, it like implicitly is about paddle input. So if I wanted to, now it wouldn't be crazy to just call this handle input. And maybe I'll do that, because I sort of prefer having nice short names where everything lines up. Oh, back to column selection mode, where I can just delete all that. Look at how great that is. That's awesome. And then I also need to switch for this and update it. And like I could even rename this to like update X, update Y, but this is fine. I think, at least in my opinion, I don't know. So this is a huge improvement. I'm gonna save this as a git commit. I'm pretty sure all those changes are relevant, but I like to use git patch mode to make sure my patches have like exactly what I want in them. So if I'm ever going back and looking over the history, the commit history, I like can really understand each individual patch. Okay, so I'm now, I think, unsurprisingly, going to do kind of a similar thing with the ball code. Just some more like copying and pasting. And I suspect these constants are going to end up being in a separate file too. But for now, I'll just start here. Now, one disadvantage to this refactor that I need to sort of keep in mind is that there's a fair amount of code duplication going on between the ball code and the paddle code, because I mean, if I were working in like C++ or like any sort of object-oriented programming language, or just like any real programming language, there'd be some way to sort of express the fact that the ball and the paddle are both sort of like entities, physical entities in the game world. Like whether you want to do that via inheritance, like you do in Java or C++ or C# or whatever, or if you want to do like a sort of component model, the way that like Unity does, and I think this is kind of like sort of modern, state-of-the-art, trendy way to handle game development. Regardless, there's some way to really share the code cleanly that I can't really do as easily in Game Boy assembly language. So because of that, there's like a bit of code duplication between the ball and the paddle. And I do want to try to minimize that. But by putting the ball and the paddle into separate files like I'm doing now, it's going to be like less obvious. Unless I'm like trying to somehow keep both of the files in my mind. So I definitely want to make sure that ideally today I figure out some good ways to refactor that and to clean that up. Okay. So similar sort of thing as what I did before. I'm going to just build it and then use the errors to guide the changes I need to make. So for example, I need to include the input constants in ball.asm. Yeah, there we go, look at that. And you see the ball, there we go, the ball also uses the paddle constants. And I suspect that breakout no longer uses the paddle constants, or the input constants actually, so I can actually get rid of these here, I think. Yeah, look at that. And then I need to export setup ball OAM. I need to export update ball. And this is kind of what I mean about these sort of like commonalities, like these exact same procedures, or the paddle versions of these procedures, are what I exported from the paddle module. The setup OAM, the update, and the init. And so if I were writing this in C++, I might define like an abstract base class, which has like a setup OAM method, an update method, and an init method, and then have the ball and the paddle be subclasses of that and implement that, or I might, use interfaces or whatever. But we just don't have that kind of expressiveness on the Game Boy in assembly language, so we just can't do that. We just kind of need to sort of use our own structure. We can't enforce consistency in the same kind of way, which in some ways is kind of good-ish because, it means we're not constricted, but is also bad because, it's harder to keep things in mind when everything is maintain consistency if you don't have any mechanism for enforcing it. And also there's like certain things that you can do with the expressiveness that subclassing, that polymorphism gives you. Like I could create a list of all the entities and just iterate over it instead of manually having to call update ball, update paddle. I could just iterate over the list of entities and call update on all of them. And I actually can, and possibly if I were making a more sophisticated game, do something along those lines where I store a list of like pointers to procedures and then jump to all of them. But for breakout, I don't think that'll be necessary because you generally don't have a lot of stuff going on all the time. It's kind of like a fixed number of things that could possibly be going on in a breakout game, at least a really simple one. as you know, I know that like some versions of Breakout, like Arkanoid, have enemies that move around the screen and power ups, and maybe eventually it'd be worth kind of like creating that kind of structure. But for now, I'm going to avoid that. So then the other thing is this negate HL method or procedure, which is poorly named because it doesn't actually negate HL. It negates what HL points to. I don't. I'm gonna put this in ball as well, even though it's kind of like a general purpose math procedure. I don't think we're gonna be negating a whole lot of other things. So I'm just gonna put that in here. And I might rename it afterwards too, but that's what I thought. Oh, I didn't have column selection mode enabled. So I might just keep it enabled. It's really useful. So we build now. I'm going to reload the ROM, make sure everything still works. Unsurprisingly, everything still works. So let's. I think it's probably good to just save that diff as is. You can see now. Look, Breakout went from being 400 lines to less than 100. It's down to only 70. I might even want to break it up even more by like, you know, putting the interrupts or in a different place or something. Like the VBlank stuff in a different place. The init code in a different place. But for now, I'm happy with this. Like, it's less than 100 lines. I'm happy. Like I said, that's my criteria. So let's, again, create a commit and save that. Yeah, the ball code is over. Yeah, the ball code is nearly 200, which sucks. Let's see what we can do about that. Right. So I guess the next thing to do is to try to this is all fine. Like, this is annoying, but it's straightforward. There's nothing really complicated here. We're just plugging some numbers into memory. That's fine. This is all this stuff is fine. It's this update paddle X that is like a little bit too heavy duty. So what should we do here? So one thing I wanted to do is we're doing this thing where we're sort of temporarily moving, but we're not writing the new result back into memory, and then we're doing a bunch of tests on it, which is like nice. It's probably closer to what I do in C or C++, but in assembly language, like keeping track of everything that you've got in your active registers is tricky. And like if I wanted to insert some code somewhere, I need to make sure I don't break this invariant that like the entire time HL is the new location, which like limits me an awful lot. And also, yeah, this especially if I want to try breaking this up, which I ideally would like to do because it does fit on screen, which is sort of my litmus test, but it's got like a lot of jumps. Like a lot of comments. Like comments are important, but they're also an indication that your code isn't as clear and straightforward as it could be. Like comments should sort of be a last resort, in my opinion. So what I'm instead going to do is I'm going to move and write that number back. And then none of the collision detection code like depends on having not moved. So yeah, that's what I'm going to do. I'm going to move, write the result back. Then I'm going to check to see if there's a collision on the left. And if there is, I'm going to move the paddle back, or keep the paddle from going off screen. We're going to move the paddle back on screen. And then if there's a collision on the right, I'm going to move the paddle back on screen. And all of these can be done independently. So that'll break this up into 3 different methods or procedures. The terminology between methods, procedures, and functions, or whatever you want to call them, doesn't really matter. But like, I probably shouldn't call them methods. That's a real like C++, Java kind of thing. Sorry. This can get split up into 3 separate procedures. None of them need to have any kind of dependency on one another. And it'll be like much easier to understand. Each one of those procedures is going to be straightforward, simple. So I'll have like apply velocity. See, like this comment, for example, add velocity to position. We don't need that anymore because we're just going to do it. Like, we're just going to do it. And then we write it back. And because there's faster ways of doing this under normal circumstances, but because the result of the computation is already in HL, it's easier to just, it's kind of nasty to just copy it from L into A, and then A into the absolute register memory location, and then from H into A, and then from A into the absolute memory location, instead of like trying to use the Game Boy's thing where you can put a pointer into HL and auto increment it on write. Like, it's just not worth it. So now we just, instead of having that comment that explains, oh, here's where we're applying the velocity, we just call apply velocity. And then I have and like same sort of thing. Check for left side collision. We don't need that anymore. We're just going to put in a procedure that's called check left collide. This will require some tweaks, but it should be pretty straightforward. Yeah, I just don't need that comment anymore. So we're going to get we have to get the paddle's pixel position again. And then that's it. You just return if we don't carry. This comment was just copied and pasted from the ball code, so like we're not moving. We don't have this write back code, so we just say load HL. Like if I wanted to get like really like aggressive about optimization, which maybe I do, because collision detection code is like, I mean, it runs once a frame. I don't know. Like I could load HL right at the beginning, and oh, this is fine. um, and then I just do a similar thing on the right. And what is it? We compare to 160 minus paddle width plus 8. And I return, in this case, if there's a carry. And it's much the same thing. I'm just copying these from here. So what is it? It was 160 minus paddle width plus 8 minus 1, and then writing it back. And you can see, so much simpler. This is like a huge improvement. The only other big change that I want to make once I figure out exactly how to do it is like how to share this apply velocity code, if at all possible, between the ball and the paddle. So I'm going to build that to make sure and then check that I didn't break anything again. But yeah, this feels pretty. This is correct. This is what we want. So let's. Let's do that. Okay, so given that, I'm going to apply a similar sort of thing to the ball code. Yeah, and here is, it's even worse for the ball, because the ball we have to apply the velocity x and the velocity y, and we've got separate procedures for each of those. Yeah, no. Okay. So I'm going to take this, I'm going to put these apply velocity procedures next to each other. I'm going to get rid of these comments because we're not going to do that. I'm going to, since they're local to this module, I'm going to call them apply velocity x and apply velocity y. I'm going to do what I did to the paddle, and right in the apply velocity thing, I'm just going to do the right back. I'm going to A, L, I'm going to do the same sort of thing down here. So this procedure is for y. Get rid of that comment again. Like everything I said before about the this kind of refactor that we did for the paddle still kind of applies. I probably maybe won't talk an awful lot because this is almost a mechanical translation, really. We're just going to be able to get rid of this write back code entirely. We're just going to check left collide, call check right collide. That's going to go in here. Of course, we need to actually make some changes to this code. We can't just copy it wholesale. Okay. Right, instead of this negate H, oh, I see. So I wanted to reuse the same logic for okay, I'm just going to keep the negate HL as is for now, although I might change it. Maybe not, I don't know. So let's again make that same change here. Is that what it was? Yeah, okay. And that comment wasn't even right. Just left of the right. Like, man, it's just so much better. Even with this like duplication and this poorly named undocumented procedure, it's just so much better. And now we got to do the same thing on the top and the bottom. Top. So one thing that I did, I don't even know if this would be a problem, but I did put check paddle collide before, in particular check bottom collide. The subtle dependency is kind of unfortunate, but hypothetically, we could do check bottom collide. I need to spend more time thinking about it than I want to right now. Bottom collide puts the ball on top of the paddle. I'm a little worried that it would trigger the paddle collision code as well if we did it afterwards. So just for the sake of, I don't know, saving me some trouble later on, I'm putting check paddle collide first. And then we can get rid of all of these. Okay. That becomes C. This becomes let's see. This just becomes wet at the end. I need to actually get the position. Okay. We're going to get the ball's Y position. Like now I can actually add some useful comments. So like, I don't think it would make sense to break this particular procedure up even more. In theory, I could. You know, each of these could be their own thing, but I don't think that's worth it. It would also get kind of tricky because we want to abort the logic early, I think. And so we need to start like somehow communicating that up the call stack, and just not worth it. So I think this is probably fine. Okay. I should do it for the paddle collision. Now we need to do it for the top and the bottom. Those are luckily a little bit simpler, so this should be faster. Just really similar sorts of things. Update the comment. Yeah, there's a very pleasant side effect of this refactor. I'm catching all the comments that I copied and pasted without actually updating properly. good Lord willing, I haven't made any like super egregious mistakes anywhere. So this will be this. If I did, this will be kind of a pain to debug. Less of a pain to debug than it would be if I hadn't done this refactor, but still like a pain. Um, so what do we want to do? Let's see here. I'll need to like think through all the sorts of things I had to think through when I first originally wrote it to figure out where the bug is. Easy. Does it build? It builds. Just clean up some of these tabs. I don't know why it's tabbed so aggressively. Okay, cool. And now I'm going to reload and see if I have done anything terrible to my code. Oh, I have. Oh no. Look at that. That is not good. It looks like we're bouncing off the left, right too aggressively. Oh yeah, look at that. I screwed that up on both the left and the right. We want to be looking at the most significant byte, not the least significant byte. I'm playing it kind of fast and loose with the collision for those. Okay, now it feels good. Does it bounce off the pedestal? It does. Cool. All right. So this kind of was a big diff, but really, really good. That was careless of me. I shouldn't have just gone through it, but I'm pretty sure there weren't any changes in that I didn't want to include in the commit. Okay, so good. Yeah. Yeah, that was such a dramatic change that Git actually thought I just completely rewrote the entire file, which is hilarious. I am going to be right back. We'll see if we can somehow combine this, and this. That's going to be my next refactor, and then after that, I just want to make some very small quality of life improvements for the rest of this stream. But yeah, be right back. All right, and I'm back. I am ready to code. Cool. Okay. So, right, this was the thing. I have this apply velocity code. In a normal programming language, C, JavaScript, whatever, I just write a function. I mean, you wouldn't even need a function. Like in a normal programming language, this is like this dot velocity equals, or sorry, this dot. Like it's so straightforward. Of course, here we need all of this code, and apparently we need it for every single thing, and that is not acceptable. I mean, breaking it down, we start to like I could, break this down and be like, well, we don't have like structures or whatever. And maybe we don't have operator overloading, so now it's like oh no. Yeah, I'm just trying to, I know this is kind of silly, but I'm just trying to sort of break this down from the high level all the way down to the low level. It's probably unnecessary, but this is the paddles. We don't even have a Y. So let's just focus on the X. And then like, this is a 16-bit number when we don't really have support for 16-bit numbers. So because the CPU doesn't have support really for dealing with 16-bit numbers in an efficient way, like we need to do this, like show it as an actual function. So then we could do it, like we could return the result and have a function called add16, which takes 2 pointers and returns the result in HL. In general, I prefer not returning results if at all possible, so then we could have like a destination to write it into. But then we have the problem that like it's really hard to pass arguments in a clean way. On the Game Boy, because like I could stuff like one of the arguments into HL and the other argument into BC or something like that. But then you end up not really like saving anything because the bulk of this code is just kind of like juggling these different juggling all the different 16-bit values. So what I'm actually going to do is instead of using a function, I'm just going to write a macro, I think. I may regret this, but I'm going to call this macro. And I mean, it's basically going to be the same as this. God, I don't know what happened there. Basically going to be the same as this. The only difference is instead of that, I'm going to use, yeah, okay, /1 is the syntax for, then /2, /2, /2. So this does assume like the hope of reusing this does assume a very consistent structure for things, but I think I'll be able to get away with it. So instead of call apply velocity, I just run apply velocity and oh yeah, okay, use a comma. So apply velocity, and this is paddle velocity x. We're going to apply it to paddle x. Does that build? Oh, yep, it builds, cool. And then the next thing I'm going to do is I'm going to move this out into an include file. I'm going to call this, I don't know, maybe entity domain. So I'm going to assume this is a place where all sorts of macros related to entity movement. The ball is an entity. The paddle is an entity. They're all going to go in here. If there's any constants related to entities, they'll go in there. So then we can get rid of this apply velocity x, this apply velocity y. And I'm just going to go here, and I'm just going to be like, call this ball velocity x, x. And this is, in terms of like code, this isn't saving us like compiled code. It's not actually saving us an awful lot. We're ever so slightly saving some code because we don't have the call and return anymore. This is just getting embedded right in the update procedure. But in terms of like reading it, it's a lot nicer. I'm tempted to do something similar for the reflection. I probably will. Make sure this builds. And let's test this. Something went terribly wrong there. How long has that been broken? This is all, so I'm going to stash this. So So we just get back to like the most recent commit that we had that worked, that we think worked. Okay, so I broke this somehow with these changes. It doesn't really track, but let's find out what happened. Hmm. 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 Like it's very curious, right? Because we're not changing the collision code, we're changing the movement code. So it doesn't feel like this should break things, but it does. Which is no longer detecting a collision off the right side of the screen. Huh. Okay. Well, here's what I'm going to do. I'm going to start factor velocity. Into a macro. And then I'm going to stash my ball changes. So the ball has gone back to using this function. And then I'm going to build again and reload my ROM. Just like as a sanity test, the paddle changes didn't affect the ball. Oh, but the paddle code is broken too. The paddle collision code is also broken. Just super curious. What is going on? Well, the paddle collision code is easier to follow. So oh, I know what's going on. Forgot to delete the return. So we were jumping out of the update procedures after having applied the velocity. That's what was going on. Yeah, this works now. Yeah, there we go. Nice. Okay. Ooh, gave me a little bit of a scare. I didn't know what was happening there. And get slash pop. I should just, to be safe, having done that, I should just, to be safe, make sure everything is still working. Everything is still working great. Cool. So I'm now going to amend that commit. And I'm going to do something similar here. I'm going to call this reflect and make this a macro as well. I just prefer that over like passing a pointer to this negate function, uh, and then you know updating the pointed to value. I feel as though that's a recipe for unmaintainability, and I prefer using the macro, even though it's going to bloat the code a little bit. That's I don't know if that's a good call, but it feels better to me. In my experience, like 99% of pain in terms of understanding code, assembly language code, is trying to write functions that take arguments and return things. Just because the Game Boy is so limited, um, like for anything besides something that takes or returns like an 8-bit value that you can do entirely in the accumulator, it's just so much easier to reason about things when you're not trying to put like stuff things in registers and pass that to and from procedures. It's become so hard to think about what's going on with the registers. So I just really prefer to use macros in these instances. Again, that's just me. That's a matter of taste. This bloats. This adds a bunch of code that gets duplicated now, which chews up ROM space. So it really may not be the right thing to do, but I don't know. I feel good about it in this case. So having done that, let's store that, and we're done our refactors for the day. So we've done our refactors. So there's some changes I wanted to make. One change I wanted to make is really, really simple. It feels like when the ball goes off the bottom of the screen, we're waiting too long or we're detecting that collision too quickly. And that made sense for when we were bouncing the ball off the bottom, which is what we were originally doing back when there was no paddle. But now that we're killing you when the ball goes off the bottom of the screen, I think it'll look better if we let the ball fall off completely before respawning. So that's easy. That should just be 160. Possibly 168? I don't know, let's try this and see how it looks. Very, very minor little tweak, but I think it'll look a little bit better. And yeah, that's it. That's all. And I think that looks better, so I'm going to go with that. And then the next thing that I want to do, and this is probably the last thing I'm going to do for today, is this is hard to articulate and you can't see my keyboard, but reset. So right now, the ball is on the paddle and we need to launch it by pressing the A button. And same now. But one problem is that if I'm holding down A as the ball goes off the bottom of the screen, it just launches immediately. And I'd rather have to make the player explicitly press the button to get it to launch. So that way they don't end up inadvertently launching it too quickly if they happen to be holding down A for whatever reason. I think it'll just feel a little better, and this will give me an opportunity to show um, something that, like, some important changes that I want to make to the input system in general. If you're making a different kind of game, this could be like super important. Um, like effectively, turbo fire is on all the time right now, and that's what I want to change. Um, and in some games, like this is really important. Like imagine if you're making an RPG and you're menuing, like you don't want to just the player to tap A or press A and then like it immediately zooms through the menus. So I'm going to create a different variable here called keys pressed. So keys pressed is basically like what has gone down in this frame. What was not pressed last frame but is pressed this frame. So to do that, we're just going to track what the last frame was. So we will need an init input procedure here just to clear that out and get that into a sane space. We actually want this to be, because 1 indicates the button is not pressed and 0 indicates that the button is pressed. We want to set everything here to like simulate at the beginning of the game. Everything is unpressed. So next, what we're going to do, okay. So the first thing we're going to do here is we're going to take the keys that are currently down and put that into last down before we read the input. Then we read the input. Then we're going to, we want to find the logical operation where if something was unpressed last frame and it is pressed this frame, we're going to get a 0. If something was unpressed last frame and still is unpressed, then we want to get a 1. Just do this classic truth table style. So if something was pressed or down last frame and down this frame, we actually want that to be a 1. And then if something was down last frame and up this frame, we want that to be a 1. Oh, so what logical operation is that? I mean, it's not and. Is it nor? I think it might be nor. Right, because or is 0, 0, 0. 0. No, it's not or, because then that is that. So it's not nor. Is it NAND? It might be NAND. Because NAND is Hmm. It's not NAND either, because NAND is NAND is that, and that's not what we want. Oof. Oof. And of course, it's not XOR either, or in XOR. So that's symmetrical, like right off the bat. So, yeah. So there's no single logical operation that the Game Boy supports that'll do this. So we'll need to get a little bit cleverer, which Lord knows I don't know if I'm capable of right now. Ugh. Yeah, we need to get a little bit cleverer. So it's probably easiest for me to actually do this in reverse and then translate. So let's assume we're dealing with this is in reverse. So we could first eliminate, we could do an XOR first. And that'll get us to that. And then we can apply a I might need to sleep on this. I don't want to bore you guys while I try to figure out some bit manipulation stuff. I think the first step probably is to XOR it, and then to do something else to strip away like the previous frame or something like that. But I might just call it for today and then think on this and start tomorrow by giving you the answer. No one wants to sit here and watch me struggle to think. It's something I'm not very good at. So I think I'll drop it for now and fix this tomorrow. Thank you very much for watching. This video is going to go up on YouTube along with the previous days. So you can follow along and catch up on anything that you might have missed. Yeah, tomorrow we're going to get this done. We're going to add support, I think, for a button that will let you move more quickly. And then we'll likely have some time, so we'll actually get started on laying out some real bricks and possibly even detecting collision with those. So it should be a really good, exciting day tomorrow. Please watch. Please clap. Yeah, take it easy. Have a good one. I'm out.